So we have got this surround sound system which I didn't throw away and I did not give up on. Not everybody was too happy with the outcome of us having changed that chip the last time. So we are revisiting it. Because in life you can either give up or make a decision. In this case, we're about making decisions. So we're going to dig into this a bit further. I've already been digging, but I'm going to show you where I've been digging and what I've found. So I'm going to plug it in. And what is happening is the power light is staying on. And if I go to if I go to the Xena diode over here, which is pin 2, we have 17 volts present. Now that's just staying there like that. Okay, 17 volts. Now I suspect there's a problem with this chip. Now let's just go back to about 300 volts. Let's go to startup. It's pin 5. If you go to that diode over there, we measure how much. We're measuring about 480 volts. So the red light is still lit at this stage. Right. Helps if you hold your probe onto it properly. Okay. So if I look at startup on pin 5 over here, we see 300 volts. That's this point over here. So this thing has got 300 volts on it. Now if we have a look at what's happening on one of the output pins, we can see there's some activity at this stage. Now if I go to it's a bit hard to see, Xena diode 508, that's that one over there. Feedback 508. So that should be a 9 volt 1 Xena diode. So let's have a look at what it's doing. Set this down to 10 volts per division. We're not seeing anything out of that on that Xena diode. So let's hit the start button. Now what we are seeing go to 100 milliseconds per division. slow the scope down. That was possibly a bit too slow. We are seeing that it's pulsing, and it's not starting up. So that's the voltage on our feedback pin. So that should be staying at a steady voltage, and it's not. So if we go back to 300 volt scale, and back to pin 5, we can see that it is just pulsing and it's not staying alive. I think there was a song by that name. So something is going on here with this chip. It's attempting to start, but it doesn't keep going. 3 volts. Let's go to 10 volts per division. The wrong way. So yeah, it's attempting to start. And I can see the power light flickering at the same speed as that. So what's going on here? Theoretically, U502, let's keep my pointy thing, not stick my fingers in here, because this is all horribly alive. That's that optocoupler over there. So let's have a look at what's happening on the one side. So the one side is 0 volts, and the other side we've got the pulsing 12 volts. Okay, so there's a clue. That thing is starting up, and then this thing starts pulsing. So our problem's not there. Okay, let's cycle the power. Being careful to not turn my USB hub off in the process, so otherwise this microphone's gonna stop working and I lose decent audio. Right, let's turn it back on. Right, so we've got a continuous red light, which is another sign that we don't have a problem with our power supply. So currently feedback is being held low. Okay, let's go back there. 2.7, right, so that's that would be the transistor voltage over there. Alright, there's a little bit of noise on it. So this thing appears to be alive and functioning correctly. So what we need to do is investigate the other side. Alrighty, so what I'm going to do, gingerly remove the probe from, I had it on, that's 507, I had it on the anode, which would be your ground. This probe doesn't have any ground around it, it's just the live bit, so it's reasonably safe. Right, let's find 0 volts, which would be chassis. Okay, let's go back to where's our circuit? That optocoupler. So that basically, I put these things side by side. Looks like that. Like so. So that opto comes in from here. So the secondary is our TU, that's our signal. Goes to that inductor, so that secondary, which provides 5 volts, should hold that signal in a certain state. Let's have a look. One side that's 3.6 volts. The other side is, let's have a look. We've got 5 volts. Sort of. On the other side, 3.6. Turn it on. That's gone down. Now 5 volts, no longer staying at 5 volts. Of course the supply is flickering, it's not staying on. I wonder what's going on with this thing. I wonder if it is not folding back because of a current draw related issue. once it's asked to start up. There must be current measurement here somewhere. RE514. That's a minus 27 volts. That's a snubber. That's another snubber. Now on this, the pin's not actually connected, so they're not looking at the current over there. So I wonder where they are doing that. Because looking at it, if we count across, there's our 12 volt pin, and you can see it's not coming up. Now 2, 3, 4, and that's supposed to be 5 volts. That's also not coming up. Now it's come up. This thing had defaulted to the red light for off. However, the moment I try and start it, it's not doing it. Let's check if we go across, third pin over, there's our 12 volts, and there's our minus 27. So I don't think we have a power supply problem. Try to keep my fingers away from the juicy parts. That's 5 volts. That's 5 volts. Over there. Oh dear. See, in this thing's previous life, this card got pushed down and it contacted the chassis, and that's when it all went wrong. Let's unplug it, because we don't like sticking our fingers into live stuff. Now this is all cold to the touch. That light is still on, that goes out. I haven't looked at that. That's the power stage. That's the other half. I'm looking at this tiny printout. That's the IC that we changed last time for for the power stage. Why don't we have a look to see if that is actually powering up? So, not happy, that's for sure. Let's just poke around and see what we find. Yep, it's alive. There's 40 volts. Yeah, it's a 40 volt supply. So you got 0 volts and you got 40 volts. So that's correct. So that's doing what it should. And I think the 5 volt supply, or the logic supply, is doing what it should as well. But something is wrong with the signal over here. Which is a signal to come alive and stay alive from the micro. So I have a suspicion that something has happened to this micro. That's a pity, because that, boring finding a second-hand board, not something we can do something about. It's just unfortunately like that. So I may actually have just misdiagnosed this originally when we thought that was that part was bad. Still got the old one, we didn't throw it away. We don't do things like that. Like I say, we don't give up in this life. We make decisions. Decisions is what makes you progress in life. So it makes you a better person. Yeah, that's a pity. I guess this audio amp probably works. One could probably use the audio stage. One could use this thing just as a audio amp. One would not be able to use the CD player and the logic part of it, but I'm sure that if one hacked into these audio signals here, you could use this as a nice audio amp. I wonder if that would make a nice project. What do you guys think? Should we do something like that? Only apart from throwing this thing away, we may as well have some fun with it at this point. What one could do is hardwire that signal so that the 12 volt stays on. Look, we know that well, we're not too bothered about that. All we want is the 40 volts for the audio, which is alive at this stage and working. So could feed this thing some audio and see what happens. But that's kind of one of those rainy day projects, you know. I think we've reached our conclusion on this one. We've been at this for a while now. My goodness. What we do on our days off. Entertaining YouTube and internet land. Ladies and gentlemen, I think we're going to call this a wrap at this stage. We understand what's going on here, and we made our decision. We did not give up, we made our decision. It is like that for this. So, it wasn't in vain. We learned something. It was interesting. Thank you for being here. And take care. Join me next time for more. Cheers.